Hello class and welcome to lesson 2.4a, mid-chapter review. Let me just double check here that we're recording. I want to make sure we're on. Yeah, we're on. Okay, good. Alright, that should exit in a second hopefully. There we go. Alright, so today we're going to take a quick break, make sure that we're up to speed on what we've learned so far before we continue on into doing some rational expression work. All right, so here's some warm-ups, ladies and gentlemen. Again, if you want to pause the video, give these a try, and then take it up. That's probably more suggested than to just follow me. However, if you want to do it with me at the same time, I'm okay with that as well. Just make sure you can do these for your upcoming test. All right, so look at the first one, ladies and gentlemen. We're going to start off with some decomposition. So it's going to be negative 2x squared plus 6x. Then we're going to do a subtract sign, and be careful here because we're going to do square the binomial. So it's going to be x squared minus 8x when you double the product, and plus 16. Again, you square the first, double the product, square the last. Okay, if you need to do that, double the product, 2 times x times negative 4 to figure out where you get that middle term. That's the middle term for that. All right? Okay, now I've got to apply my distributive law to the negative out front of the bracket. So it's going to be negative 2x squared plus 6x minus x squared plus 8x minus 16. Now, if you wanted to, ladies and gentlemen, save what the distributive law over here, you could have done that after you did the exponent. So it's really not going to affect, if you're thinking of order of operations in bed math, technically you should do this part first. However, it's not going to impact the answer because of its order. All right, so collecting like terms, we end up with negative 3x squared plus 14x minus 16. So there's that one. Taking a look at the second one, ladies and gentlemen, notice we've got a binomial times a binomial squared. Here's where we do have to do bed math. You have to do the exponent first, so you leave the first binomial out front. Okay, and then we're going to square the first, so that's going to be 9f to the fourth. Double the product, so 2 times 3f squared times negative 2f is going to give us negative 12f cubed. Okay? And then square the last, ladies and gentlemen, is going to give us positive 4f squared. All right? Okay, now we're going to apply kind of like our distributive law. We're going to multiply everything in the binomial by everything in the trinomial. So we're going to have 18, I better write small. Let me just start this equal sign over a little bit more because we got lots of terms to try to fit in. Okay, so 18f to the fifth minus 24f to the fourth minus 8f cubed plus 45 f to the fourth. Okay, and then we are negative 60f cubed. And last we're going to have plus 20f squared. All right, collecting like terms, we have 18f to the fifth minus 21f to the fourth. Okay, and minus 68f to the third. And no collecting like terms of this, so it stays plus 20f squared. All right, that's just, sorry, a squiggly mark on my smartboard. That's not me just writing bad today, which will happen on other days. Okay, so there's B. Let's try number 2. Determine whether this pair of functions is equivalent. Okay, notice, ladies and gentlemen, that A is in standard form and B is in vertex form. So what I'm going to do is I'm going to expand this one and see if I end up with the first one. Okay? Otherwise, you could have done all the opposite. You could have factored this and see if you ended up with that, or completed the square and see if you ended up with that. All right? So it's either case, but I always think it's easier to expand than to factor or complete the square in this case. All right, so I'm going to realize leave the 3 out front, square the binomial, so it's going to be x squared minus 4x plus 4. Don't forget the plus 4 at the end. Sometimes people Missed that. Distributive law gives us 3x squared minus 12x plus 12. Then don't forget plus 4. Collecting like terms, we have 3x squared minus 12x plus 16. So is h at x and g at x, oh, I apologize, there's supposed to be a g here. That's okay, we'll call it b at x. Somehow my, should look like this. My version, I guess, isn't saved. So if it's g at x on your handout that you're copying, fine. If not, leave it at b at x. But regardless of the function notation, we know that h at x does not equal g at x. Okay? So no, they're not equivalent. Good. All right, let's do some factoring practice, ladies and gentlemen. Okay, notice the first one, ladies and gentlemen, is 4 terms, so always look to factor by grouping. So the first 2, ladies and gentlemen, have common 5t. So what's left over is t minus 3. Trying to look at what's common in the last 2 terms, I notice that I can take out a negative 6, so what's left over is t minus 3. Notice you've got a common binomial of t minus 3, so that becomes your main factor, and your other factor, which is your leftovers, is 5t minus 6. Okay. Looking at B, it looks like a difference of squares, but we realize because it's got a difference, but it's not a perfect square, so we need to look to common factor first. So we notice that 3 goes into both, so it's going to be r squared minus 9. Okay, and then we do our difference of squares, ladies and gentlemen, so we put a positive, negative, doesn't matter where you go. Which one goes first? R squared, square root of that is r, square root of 9 is 3. And there we have it in factored form, ladies and gentlemen. Last one is the tricky one. It looks like decomposition. However, we can common factor first and see if that will make things easier, which I think it will. So 3 goes into every expression. So what are we left with? 10w squared minus 3w minus 1. Although we've made it easier, a still does not equal 1, so we will be doing decomposition. And sometimes I just do I like to write decomp as soon as I know, so that I know to split the middle term. All right. So what I need to do is figure out my product equals 10 times negative 1, which equals negative 10. And my sum equals negative 3. Okay. So what 2 numbers am I going to figure out? Negative 5 times 2 will help me with that. I'm just going to move this down because I'm running out of room. Up there. So this is going to equal 3 times 10w. And I'm going to split that middle term, so I'll make my arrows look a little bit more realistic here. Alright, so I'm going to split it to minus 5w and plus 2w. And again, if you had it the opposite way, no worries. You'll just come out, you'll just be grouping a different common binomial. All right, let's do that. So I'm just going to make a big bracket, make life easier. First 2 terms, what do I have common? I have a 5w. So what am I left with? 2w minus 1. Okay, looking at my last set. There's nothing really common, however, positive 1 is what I can take out because it does exist. Okay. So to finish this off, my common binomial is 2w minus 1 times my leftovers, which is 5w plus 1. There we go. Decomposition. So there's a good warm-ups, ladies and gentlemen. So today we're going to be doing a chapter review. It's a work period. So see me today if you have any issues with the following: simplifying polynomials, multiplying, collecting like terms, determining when functions are equivalent, factoring, any of the 5 types. So here is the work for today. Page 107, numbers 1 ACE, 2 BD, 3, 4, 6 to 9, and 10. Have a great day and happy working, happy homeworking. Have fun.